Hello, everyone. Thank you for joining. This is the Working Group Serving weekly meeting. Remember, this call will be recorded and uploaded to YouTube, and we are following the CNCF Code of Conduct. It's great. It was great to meet a lot of you at KubeCon in person. I hope everyone enjoyed the time, the sessions, and all the networking there. And we have some open topics today. But before that, we'll go through the workstream updates. I don't believe there's anything for orchestration. DRA, Sergey, you want to provide an update?
Yeah, for DRA, we don't have many updates. As we discussed on KubeCon, many questions were around how to GA DRA, like what will it take to switch to from device plugin to DRA, and all these questions are dominating the DRA space right now. So we're trying to understand how we'll GA everything. One interesting discussion from yesterday meeting, device management group meeting, is increased pod startup latency because of all this flexibility that DRA introduces, and resource slides that needs to be queried, and claims, and advanced not preparation for devices. We get quite a delay in additional delay in pod bootstrapping. So right now there will be some measurement efforts, like somebody will measure what is the baseline of introduced latency, and this latency is kind of built into DRA design, so it's hardly can be eliminated. And depending on what it will be, we can start making other decisions, what we can do to improve it, and maybe some other areas to improve to compensate for this increased latency. But yeah, that may be very relevant for this group.
Thank you, Sergey. Is there anything that we can redirect the folks to, like any link to the discussion or recording? Maybe that would get
Yeah, there
more
is a
folks involved.
meeting was recorded, but I don't think recording already uploaded.
Okay.
I will try to paste as soon as we have a recording.
Okay. Yeah. Let us know if there's anything we need to engage with the other working group.
Cool. Thank you.
Okay. Auto scaling updates. Multi-host. Is Josh in here? Or Abdullah, do you have any update?
Edwin can probably chime in here. We've got, I think, a couple of kits ongoing. Edwin, do you want to talk about them?
Yeah, so we have pod group caps, which would allow integration with other schedulers to allow for again scheduling. Currently, it's under review. We also have create a no group per replica as a solution for a race condition that we found. And I'm also currently investigating adding the research claim to support to LWS.
Cool. Yeah, thanks. Would you mind adding some of the updates to the Google Docs as well?
Yeah, I'll add the links.
Okay, thanks. Any comments or questions? Okay, let's start the sub-project updates. Kellen, do you want to provide an update for GIE?
Sure. Yeah, I mean, the bullet points are our high levels. We released v0.3 for KubeCon. There's been a lot of announcements around this product, so we are really trying to make sure that the first experience is a clean one. So that was a lot of what O.3 is. We are going to be focusing on some feature expansion, namely prefix caching and a queuing system. We're calling it the flow controller. There's and will be a few proposals around some re-architecture. We're changing how we're managing scheduling. We want to make things a lot more extensive, pluggable, etc. We go into that further in our meeting tomorrow. If anyone is interested, we'll dive a little more deeply there. And then, yeah, we are drafting O.4. I'm trying to focus more on what features we'll be adding. So as you show here, the changelog can be cleaner and more succinct, more reader friendly. but we will be continuing to invest in scale testing. We need to know the limits of the EPP, which is the core binary for GIE. So that is what we're working on and have been working on.
Cool, thanks. Quick feedback. If we are like, do we have any updates around like working with other projects? Like, for example, I see that Envoy AI Gateway has integration with GIE now. Maybe that's something worth bringing up somewhere.
Yeah, it's been a while here, so apologies. I thought that was announced, but yeah, we are integrated with GKE. Envoy AI Gateway has their own implementation. It's a little bit different, and then we are Solo has implemented, and Istio. Sorry, so we have a lot of gateway implementations, which is great. Something we've sorely needed. Yeah, thanks.
Yeah, it's awesome. Those are captured in the release notes, maybe like previously?
We have them in the website. The website's going to be the most up to date. I'll go ahead and link that.
Okay.
Thank you for calling that out.
Yeah, sounds good. Yeah, because those are great features. We do want more visibility within this working group.
Completely agree.
Anything to add from others? Okay, well, good. Jason, are you here to provide an update on serving catalog?
Yeah, I am here. Sorry, I have a little bit of background noise. We have a couple of PRs that are getting merged in for some smaller updates to what already exists, and separating out max text and JetStream PyTorch. So just getting those in, and then just another call out as we come back from KubeCon, the proposal for the CLI tool that kind of adds a layer of like making these templates more dynamic and usable across different types of deployments. If we could get more feedback on this, that'd be great.
Thanks. Any comments? Okay, and Ashok, are you here? He's not here. Chen, do you want to provide an update for inference perf?
Okay, we are trying to right now merge the FMPerf libraries to the inference perf, and then I also helped set up some release spot there. And there's definitely a lot of code contributed by Google folks right now in the load testers. And the next step for us is really to support different like full inference cluster stacks. Like Dynamo, like AI breaks, etc.
Can you elaborate on what that means exactly in the context of inference perf, integrating with Dynamo and AI breaks?
It's more like providing a library to do benchmarking jobs, schedule benchmarking jobs with pre-existing full stack instead of just using FFperf to deploy servers individually.
Is there a link to the issue or any discussions in the open?
We haven't. So all of those are just the offline discussions at KubeCon. We haven't got a chance to create the issue or proposal yet.
Okay. Yeah, please keep this group posted in case others want to like join the efforts and contribute. I don't think we have a dedicated channel yet, but let's use the working group serving channel for now, unless the traffic gets heavy.
Definitely, yes. I will probably create an issue after tomorrow's benchmarking meeting.
Okay. Thank you, Chen. I think we are good with some project updates. So we have 2 open topics today, and the first one is gonna be Rob and Mark from Red Hat. Rob and Mark, are you guys here, I think?
Yep,
Let me
we're both
see.
on.
Who's gonna present?
I
I'm gonna
can
make
I
you
can
a
share my
copy.
screen. I'll
Okay.
present, and then Mark will do a demo at the end. So you might need
Okay.
access to.
Got it. Okay. Did that work?
Yep, I believe so.
Should I stop share then? Okay. Yeah, go ahead.
All right, everyone can see the screen.
Yep.
Okay, cool. Yeah, so Mark and I will walk through Guide LLM, which is the open source benchmarking tool that we created at Neural Magic and then carried over into Red Hat. So ultimately, like breaking down in terms of like the need and why we kind of built this. So the first one is around like, assessing LLM inference pain points, right? So model inference performance eval under different enterprise workload scenarios requires manual setup of these runs with varying parameters. This can be very time consuming when you're considering scale and all these different combinations and things that you need to consider when doing performance runs. Second, data compatibility and integration to support both custom data sets as well as open source data sets that exist, for example, on like Hugging Face transformers are really important when you're thinking about the accuracy evaluation piece and looking beyond just inference performance. Next, we have resource optimization. So deciding what hardware is actually suitable for your workloads and deciding that, thinking about service level objectives or what we call SLOs is really important and a really big consideration that folks need to be thinking about when they're deciding where and how to deploy these models. And then lastly, obviously, the top thing on lots of enterprise and developers' minds is cost, right? How do you reduce costs and make sure that you have good estimation and you can kind of do that math of what it's going to cost to deploy an LLM. So this is kind of what inspired us to build Guide LLM. So the mission here is basically to evaluate and enhance LLM deployments for real world inference before you deploy. So Mark will kind of go into a little bit of the user flow here. Mark, you want to take over?
Yeah, definitely. So, I mean, this is, just kind of from a high level, entire goal. So Guide LLM just sits as a running Python process and has sub-processes and things like that, but able to take in, any kind of data set as Rob was just going through, and mainly trying to influence the model selection and creation portions, right? So that we can fail early, and if benchmarks and evals and things like that aren't matching up to what people need, as Rob went into. So Guide LLM sits in that middle. It will hit any kind of currently OpenAI compatible server, which is targeted the LLM for the most part, but easily expandable out to others, and then it'll put out a guidance report in a number of different formats. So yeah, Rob, next slide. So we're going out with the next iteration and next release. We took a little bit of a pause on Guide LLM for a little bit as we're going through Red Hat acquisition and all kinds of other stuff. But there are significant expansions on top of Guide LLM with this latest release, and just kind of running through, a little bit whenever we're looking at this benchmarking piece. The biggest thing is just making sure that we aren't measuring overheads within the benchmarking process, and we're getting as close as possible to what the actual request rates are, and enter token latency, time to first token, all of those SLAs. So with the new version, it's completely refactored to use an async multi-process and threaded design. And going through a number of different measurements, we have just 0.16% time overhead time in a synchronous mode. So essentially, if you're just going one request after another and trying to hit that as fast as possible, then we are going to be at 0.998 concurrency, somewhere around there, as well as whenever we're looking at more of a constant rate or Poisson request rate or things like that, it has above 99.9% accuracy for request start times to ensure that those are going off and measuring correctly. With all of that, there's a ton of robust accuracy and monitoring built in now. This is one of the things that we figured out as we were looking at other benchmarking tools and looking at Guide LLM, the initial version, that there was a lot of overhead that we weren't accounting for. So a lot to refactor and ensure we're taking care of that. but also built-in robust accuracy and monitoring throughout the entire framework now, so that we can validate performance if if things aren't looking correct, and we can also catch regressions that are happening. So those are kind of the two biggest pieces towards the refactor. But otherwise, from a functionality standpoint, we've also expanded it out quite a bit, looking at flexible benchmarking profiles. So anybody can come in and run synchronous, as I said, one request after the other, as fast as possible. Concurrent, where you just are specifying the number of concurrent users that you expect to have. And then we're requesting as fast as possible for each of those concurrent users. Throughput, where we're throwing all of the requests at a different server at once. It's capped at a certain number of requests so that the server doesn't fail. But yeah, throwing those all at once, and then we have a constant rate where you can set a certain request per second target, and it'll constantly hit that at that rate. Or you can do a Poisson rate, which is the same thing, but it's drawing from a Poisson distribution targeted around whatever rate that you have as the mean. So it gives more of a natural distribution towards requests coming in. The final one is a sweep mode, which is going to run a synchronous benchmark and then a throughput benchmark, and then it's going to linearly intersperse between those for constant request rates. So that way you can pretty easily generate a full sweep of the performance profile for a given server and model. And with all of that, outputting all of those SLAs and things like that. Oh, and one other thing to mention is that it has full statistical breakdowns on everything, which we'll show in a demo a little bit later. Otherwise, unified input and output formats. We now have JSON, YAML, and CSV and console output, and then we have HTML and graphs coming soon. Multi-use data loaders, so we have native support for Hugging Face datasets, file-based data, as well as be able to create synthetic datasets to generate a specific load type in terms of prompt tokens, number of prompt tokens, number of output tokens. Pluggable backends via OpenAI compatible APIs. So as I said earlier, works out of the box with OpenAI style HTTP servers, but also designed to be easily expandable to other interfaces and servers. Had a few requests to have native Python calls into VLM and things like that. So we've ensured that it's architected to be able to easily expand to that. And then as Rob will go through in a little bit, but it's also architected for some of the immediate next targets, which is being able to benchmark multimodal pathways and setups, as well as being able to enable accuracy evaluations. And then here's just a quick example of what it looks like for the CLI output. On the left is a sweep that's being run. So it created some synthetic data, and I think we lost it for a sec, Rob. Okay.
Oh, sorry.
No, you're good. So yeah, on the left is I know it's a little small on here, because we had to fit both in. But yeah, on the left is the progress as it's going through. It's constantly reporting out to you, what it's measuring, and then also what the time to completion, things like that look like. And you can see all the different benchmarks it's going to run. On the right is the output. So it dumps out a ton of data to try and make sure that we include whatever you need out of the box immediately. But also there's a lot more data stored in the output files that you can grab. But just kind of quickly running through, the output on the right, you have all the benchmarks that ran. You have an info section at the top, at the very top, you have metadata, which is just all of the arguments that went in to run it. Benchmarks info, which is just going to tell you how long each benchmark ran for, how many requests were made, completed, incomplete, error, things like that, the number of output tokens, prompt tokens across each request. And then in the benchmark stats, we have the actual, SLAs and things like that. So measuring requests per second, concurrency, as well as the the output tokens per second, total tokens per second across the entire server, as well as per request metrics like request latency, time to first token, inter-token latency, and time per output token, and trying to give a reasonable variance of the data you might care about in terms of mean, median, and the 99th percentile. But again, all of these are broken down a lot more in the output files as well, in case it's not included there. Next slide.
Okay, so looking at kind of the future roadmap items that we have slotted out. So the first one is to look to integrate accuracy evaluation. So obviously coming from Neural Magic, accuracy is a really big part of quantization and optimization, right? When you optimize and quantize these models, it's really important to make sure that you're holding accuracy at a constant there, to ensure that, you know, you're not having a degradation in your performance when you're getting the performance speed up. Next, model performance comparison. So thinking about like how we can run multiple models at varying request rates across different hardware to ultimately determine the best model for your use case. This is something that we've heard customers of Red Hat notably struggle with a lot, of figuring out, okay, what's the right model for my use case? What's the right hardware? Cost estimation is another one. So thinking, how do we implement, you know, cost understanding of what it costs per million tokens, and also per week, per month, different user concurrent user rates and RPS rates and things like that. And then lastly, thinking about like cluster-wide hardware sweeps down the line, as like, you know, as these deployments scale, of deploying these LLMs on VLLM, you know, let's say you have 50 or 100 models in production. Is there a way we can, you know, kind of automatically go and designate the right hardware for what you're trying to achieve with your model and your use case, and hit those required SLOs? We also do have a public GitHub product roadmap, and I'm happy to kind of share that link out, and also this deck with this group after. And yeah, maybe I can link these in the notes that you have. Okay, yeah, in terms of like community adoption, so I think we launched this like ultimately eight-ish months ago, and then we took a little bit of a pause on it, and then after the acquisition, we kind of picked up work and kind of refocused on it. So right now we're like just under 260 stars. Haven't done a lot of marketing yet on Guide LLM, notably because we've been waiting for some refactors to land and kind of nail down our strategy and what we're trying to target. But there is some solid community adoption and engagement here, so that's been really exciting to see. And we do definitely plan to keep investing in building out the community, and taking feature requests, and obviously welcoming contributors. Notably, you know, this group could obviously offer good insights and ideas, and excited to get into that in the Q&A section. Something else that's really cool that we're planning is a UI and data visualization. So we've actually built out, so Mark showed the CLI output, which is kind of how we have it structured now. However, in the future, we kind of explored this concept of workload reports. So basically being able to generate a specific report for the benchmarks that you just ran, and really understand across your SLOs how the graphs shake out, right? So looking at TTFT versus RPS, intertoken latency, end-to-end latency, throughput, these types of metrics, being able to surface how these progress over the sweep beyond just what you can kind of see in a terminal, is something we think is really important in terms of explainability to leadership and folks who are making decisions on what models and what hardware to use. In the top right, you can also see this service level objective for task graph, which we also think is really cool. And ultimately, that helps you kind of find what that saturation point is on how many users you can actually take on, and what that maximum RPS is, where you can still meet your SLOs for your use case, right? So actually being able to map these metrics to your use case and what you're actually trying to solve for from a business perspective is really, really important. And this was kind of a way that we are focused on translating what the raw numbers are into actual, you know, value, to say, yes, this model is good enough for chat, or yes, this model on this hardware is good enough for summarization. This is kind of an approach that we took, and we're continually investing to build this out, and hopefully this will be released in the coming weeks as well. We're almost done with this. Okay, demo time. So yeah, Mark will do a short demo, just spinning up the VLM server and running Guide LLM against it to show a quick benchmark. And then after that, we'll kind of dive into questions. So I can relinquish my screen. Why don't I do that first? Let's see.
I think I might just be able to, let me see if I
steal it?
share, and if I can kick you out. Yeah, kick you out. You see it okay?
Yeah, you steal it.
Okay. All right, perfect. Sorry. Oh, there we go. Okay. All right, great. So yeah, I already have VLM running on another local server that I'm on. Just one that I have at my home. I've been doing a ton of testing, so my partner has not been happy with the electricity bill lately. But yeah, so just running the target where the VLM server is running. And then it has this model hosted. If I don't put in a model, then it's going to grab whatever the default model is on actively running on VLM. we're going to run a sweep rate type. We're going to tell it to run for 10 seconds just so that we can get an abbreviated demo real fast. Definitely recommend running for longer than that, but just to go through. And then otherwise, just going to tell it to create some synthetic data with 128 prompt tokens and 64 output tokens. You can also add in, standard deviation, min, max, things like that into these to try and get a little bit more variance in that data. But for simplicity, we'll just run this. So I'm gonna go ahead and kick that off, just giving a progress update. So it's creating that synthetic data right now, created that, and it's going to go through and start running. And as I was kind of laying out before, it's actively running that synchronous benchmark first. This gives us our lower bound in terms of request rate, and also the upper bound on what we can expect for maximum performance on the SLAs. Next, it's going to kick off this throughput benchmark. That throughput benchmark is then going to give us our upper bound on expected request rate that the server can handle, and then additionally the lower bound on those SLAs. Now that it has both of those, it's just going to go and run through a linear dispersion of constant request rates in between those. You can also plug this in to be Poisson if you want a more natural request rate. But yeah, so those are all running through. You can see it giving us the live data of what it's done so far in terms of the requests it's completed, any incomplete requests. So kind of noting for the throughput, we had a bunch of incomplete requests just because it ran out of time and had to kill those. Otherwise, it's giving you live info on how many requests per second are coming in, concurrency, things like that, as well as the stats on tokens for how many it's generating per second, time to first token, ITL, things like that, that it's doing live. After it completes one, it'll compile that report and then update these stats, and what it outputs at the end is those compiled results. So should be done in the next 20 seconds, and we'll be able to see the output. But you can see down here, just trying to give a nice UI and nice estimates for users in terms of how much time is left and yeah, just general progress. So just about done. And there we go. Let me drag this out a little bit so we can format the table better. So yeah. Why is it not expanding? I think I have something weird on my terminal. But anyways, just giving you a quick output on these. We tried to format this so that they'd be easily copyable into a spreadsheet or things like that. You just need to set the delimiter to a pipe, and these are just the results that we ran through earlier with benchmark info, benchmark stats, things like that. And you can see all of the different results that came in. So kind of running through the sweep, you can see as we increase the request rate, our time to first token is going up, but our overall tokens per second is going to increase as well. So our throughput's going up, but we're hurting that individual request latency. That's about it.
Thank you, Mark and Rob, for your presentation and demo. We do have a hand raised. Abdullah,
Yeah,
go
thank you. This is awesome. Would we be able to use this against like any endpoint? For example, not necessarily like a single server. For example, like send this traffic to, like a gateway, and get all these, scans. The thing is here, like for a single server, of course, like the maximum you need to drive traffic is probably, I don't know, 100 QPS. But if I want to test against like 10 servers, I probably need to drive much higher traffic. I don't know if this tool can do that.
Yeah, I mean, right now you're definitely going to be limited by it running on a local server. So it's whatever your outbound typically. Well, we do multi-process and multi-threading, and then all IO requests through async. So there's very minimal overhead from the process itself in terms of scalability out to a lot of requests. So the upper bound that you're going to hit is just the total data connection that you can put out essentially. There are some thoughts about how we could extend this out so that we could sync this across multiple servers to be able to increase that total network throughput rate for data, but haven't implemented anything yet. So So yeah, currently, target at single server, but also you definitely can hit a load balancer or a route, a general endpoint, and test that out. But as you said, you might hit that upper bound of what that single server can do.
Right. Yeah, we had some challenges with async IO. It didn't scale well. I mean, Kellen can speak to that as well. That's something to consider here. I don't know if it is like essential to your design or not.
Yeah, there was a lot that I can pull it up. There was a lot that we did to get around some of the limitations on async IO. Specifically, the biggest thing that I think you guys were probably hitting was, it's just running through a single core, and then obviously you're getting hit with the GIL and things like that. So the entire architecture underneath this is multi-processing through async IO and then threading on top of that. So sorry, I'm trying to pull it up. Scheduler. Yeah, here we go. Let me get rid of the terminal. What I just wanted to show real fast is where it is. Oh, run setup. Here we go. Oh no, sorry, it is down here or up here. I'm getting lost in my code. Run, and then so we're doing multi-process manager and then start processes. This is it. COC for however many processes we were requested. Essentially, each stream.
I don't think you have this shared currently if you're sharing.
Oh, yep. Sorry. I forgot that I stopped sharing.
Oh.
Thank you.
Let me stop sharing.
Sorry about that. Here we go. Okay. So so everything's built around the scheduler, but you can see that we're kicking off multiple processes, and it is so it's going through a multi-process manager for queues and threading. So there's a little bit of overhead for synchronizing there, but we gain a ton of extra abilities and general compute by launching these and multi-process. So each process is set up to match to either, if you're in a concurrent, to one user or synchronous to one user. And then if you're in one of the async rate types, then we're just launching up to a maximum. I think we set the default at like 20 cores or something like that, or whatever the max cores on your system is, -1. So anyways, just trying to call out, we definitely hit some issues with async IO in the first version, but we did a lot on top of that to ensure that we could get around that and use the benefits of async IO by throwing everything into, mainly for the requests, into background waiting logic and using multiprocessing to try and get around those limitations.
Hannah, you're up next.
Cool. Yeah. I guess two things on that thread. Do you find that your QPS is really accurate as a production estimating tool? We found that we really need accurate QPS, for obvious reasons, and we found that async IO was, when we gave it a QPS, it wasn't accurate. We didn't do the multi-core. I punted to a different tool, but I'm just wondering if your optimizations, you found that you were able to validate that your QPS was what you expect. Cool.
Yeah. So we did a number of validations. Each whenever we're running in an async mode, usually we're looking at, I think, like 4 or 5 milliseconds of overhead that's not spent in active request, somewhere around there. And with that, we are pre-calculating all the times so that we can get so that essentially we can spread that out and have it launch at the correct time. So usually the delay for the targeted request time is about 5 milliseconds, somewhere around there. But that's kind of to the point of, whenever we were doing all these tests, we were at 99.9 or above accuracy on the target rate that we expected.
Okay. Yeah. Cool. And then I think Yuan mentioned it, but it sounds like, this fits well with the inference perf effort. Is that something you guys are looking into?
Which is...
So
Go ahead.
The inference perf project from this working group. I really wish NeuroMagic could have engaged with
we
us
explored this
earlier,
early on.
Yeah, but it's okay. Now we are really open to the conversation, and we can come up with a collaboration plan together going forward Chen's also
Yes,
here.
yes.
Maybe you can
Um,
share some
we,
thoughts.
we are actually trying to use FMPerf library, the load testing library to call get LLM directly, so we can deploy get LLM with different configurations just as a job on Kubernetes to ease the load testing and benchmarking process. We are still exploring on this thread, and then I really hope to talk to Gaja team closely. And then internally, I also talked to Sally from Red Hat. I see she already tried it with, for example, the full stack deployment endpoint.
Cool. Yeah, I would love to see that collaboration. That would be awesome.
Yeah,
all I
we'll make sure Aisha, unfortunately, he's not here today, but we'll make sure he also catch us with the recording afterwards, so we can think about our planning going forward.
Yeah, sounds great.
Okay, one more hand up, Sunny.
Yeah, hi. I just have a question about this guide LLM. Is it also a suitable tool to benchmark different storage tiers?
When you say storage tiers, what do you mean?
For
For KV
example,
cache or yeah?
Yeah, for example, if we set up a PD cache and we want to compare with another different disk types, or even like something like in GCE we have like GCP we have a parallel store or different file system services. Is this a suitable tool to do that?
If you're trying to measure the differences of those systems for the deployed server for LLMs and things like that, I would say definitely yes. If you're trying to measure anything outside of that, OpenAI API or an LLM base, I would say no, but it could be adaptable towards that.
Okay, thank you.
And Rita also had a question in the comment in the chat. Can you give an example of determine the most suitable hardware configurations for running your models effectively?
Yeah. So we are it's not going to be extremely efficient right now. But to go through that, essentially you'd spin up example deployments on a given hardware. So for your targeted model, spin it up on the different distributions that you'd want to look at. And then you would point guide LLM at that with either a live data set or a synthetic data set that matches the distribution that you expect. Point it at each, and essentially you're going to get a sweep of the expected ranges for each of those setups. And with that, you can set whatever your criteria is, P99 of TTFT above this, then we know that that's the hardware that'll meet that criteria. We're also pre-compiling a bunch of data. Rob can definitely talk more towards that so that we have all this available. There's also some talks about trying to make that search more efficient. So because right now we're just doing kind of a broad sweep to be able to calculate all of those with the assumption that it's gonna your SLAs are going to be in there somewhere, or you're just going to be outside of those bounds. But there are some more talks that you can that we're trying to work in about being able to set what your target SLA is, and then it'll try and tune and figure out what request rate you can handle to meet that SLA and converge on that faster. So that's something that's for the near future, but hasn't been worked in yet to make that whole process a little bit more efficient. But overall, you'll still be spinning up, an example model, an example server to see what the request rate that can handle is, so that you can meet your SLAs.
Thank you, Mark. Feel free to send me the links, and then I can also share it with this group.
Great.
In the
Yep, I'll send those over.
notes. Yeah, thanks. Okay, we have 15 minutes left, and we do have one more topic from Andre. Andre, do you need to share the screen or?
Yeah, I think maybe actually we'll give a quick demo.
Okay, yeah, I just made you a co-host.
Yeah, so can you make actually co-host?
Okay, 1 second.
So maybe I could introduce myself. Hi everyone, I've been in this call before, but My name is Andre. I work at Apple. I also part of the Kubeflow community, helping them to build distributed training systems, and also been involved in batch working group and trying to see what we, like how we can run distributed training on Kubernetes. So actually, do you also want to introduce yourself to the community?
Hi, this is Akshay. I work at Apple with the same team as Andre. Work in the data platform within Apple.
Yeah, so just to give you a little bit of a context, what we want to present here. So we built a distributed cache on Kubernetes, which actually allows us to streamline distributed training on Kube, specifically for tabular data, using Iceberg and using iterable dataset. And actually, we'll tell more about it. But like the goal of this discussion, we will use Reader Worker set for this. And we have like a few things to talk about for these use cases specifically. So actually, I think since we have 15 more minutes, maybe we can just go over like the proposal.
Yeah. Let me share my screen.
You should be able to share.
Oh, sorry. Let me. So sorry, I will need to quit and reopen my Zoom. Let me join soon.
Oh yeah, yeah. We actually share like this proposal within the working group serving. In the meantime, you can take a look. And also, I think we gave a talk at the KubeCon about this distributed cache. Yeah, so I think general idea is we've been using the Apache Arrow and Data Fusion to kind of store Iceberg tables in memory, and actually allows us to fetch data from those memory tables directly to the GPUs, which means like we separate, we kind of like we make sure like first of all it can work with iterable dataset with PyTorch. And at the same time, we see a lot of improvements over using this way compared to default iterable datasets with Hugging Face, for example, because we reduce I/O like on the GPU workloads, and we place like more data to the CPU, and everything is like in memory. And actually, yeah, right now we can see your screen. Go ahead. Actually, I think you're mute if you're talking. We can't hear you. Actually, can you hear us?
Can you hear me now?
Now we can. Yep. Go ahead.
Yeah, sorry for the delay. Thanks for having me here in this call. So I think we wanted to actually talk about the solution which we're working on, caching solution which we have been working on, specifically targeting Iceberg tables for distributed training on Kubernetes. So I'll just quickly go through the proposal which we have. So we've shared this proposal with the Kubeflow community, and we have also talked about it at the previous KubeCon. I'll quickly go through this proposal, and I'll go through a short demo of explaining how it integrates with the Kubeflow Trainer project. So, so with this caching solution, what we are essentially targeting is to shard effectively do auto sharding of the dataset when the dataset is being accessed for distributed training on Kubernetes. So historically, there are couple of challenges when dealing with distributed training. So there are two specific use cases today, where either you stream either you load the entire dataset into memory of all the workers, even though the workers would only need a specific subset of the data during the training loop, or the training workers would need to stream the data directly from the source. So quickly, so this is something which we presented in the KubeCon, just to give you an overview. So this is the case where your the workers are actually streaming the dataset directly from Parquet files on object store. So this is the issue here is that every dataset would actually stream the entire dataset. This is the same case when even if you're using Hugging Face dataset. It says that if you don't have the workers in the same way as partition files on the object store, every worker would actually stream the data. For every epoch, the streaming would remain the same. This would incur network I/O and also serialization cost, where the workers would spend most of the CPU to actually decode and deserialize the Parquet into memory format needed for training. In the other case, when a data set is being loaded into memory, so for every epoch, the entire data set is being stored onto the memory, and the iteration would access specific shard from within the memory. So this can be loaded directly from the file system or from the object store directly. And so with caching, what we are solving is we are auto sharding the data set. So even let's say you have if you have hundreds of Parquet files within your data set in S3, we provide an easy way to shard the data set so that every worker would only access specific shard of the data and stream the data set from the cache. So specifically, in order to cache the data, we use Apache Arrow format. It's an in-memory columnar format for storing large data sets, and use the Arrow flight protocol to actually stream the data without doing any serialization, deserialization on the worker pod. Arrow is right now integrated with multiple frameworks, specifically PyArrow if you are using any of the Python frameworks like PyTorch. And so the caching itself, just to give an overview of what we have with the cache. So let's say you have a iceberg table with a number of files, and the head node would, depending on the feature set to load from the table, the head node would actually use the metadata to actually partition the files onto data nodes. So this would only stream the files, and the data node would actually load the data from the files and prepare an in-memory table. And for this specific caching, we use data fusion in a query engine. It's an embeddable query engine which works on the Arrow memory format. And we use data fusion to store the data in memory, and the head node would actually index the data or create an index table so that it can easily have the shard information for the specific data set. And during the distributed training, workers can actually use the index. Let's say depending on the size of depending on the world size, and the worker can actually access a specific shard directly accessing the data node. So this describes the flight protocol, where our rank can access a head node to get the location of the shards where the shard lives, and head node would use the query in memory table, the index, the metadata table which it prepares during the bootstrap to actually give that information to the rank, and rank can actually access the data nodes directly to stream the data. And also while streaming, the workers nodes would need not load the entire shard from the cache. It can stream the data in a batch using in a batch data set. Users can configure a batch size as well, but it can stream the data set from the cache. So the rest would be the integration with Kubeflow with the trainer. As you know, the Kubeflow trainer uses JobSet to actually orchestrate ML training on Kubernetes. So as one of the first step with training, we use initializer step to actually load the data set, and we integrated with dataset initializer to actually load the cache, bootstrap the cache with the data. We use leader worker set API to orchestrate the caching, the cache cluster, and provide easy way for trainer workers to actually stream the data from caching. Let me go back to actually present a small demo. So this example is actually fine-tuning a BERT model with Amazon Reviews dataset from Hugging Face. So and this is what so this describes how it's useful for data scientists to actually bootstrap the cache quickly and also stream the data during the training. So we are using Kubeflow SDK for that purposes to create the training jobs. So let's quickly. So using the SDK, you can access the runtimes. So runtimes are like blueprints that you already know, and we have a runtime with cache, which actually which actually has the dataset configured as an initial job. Dataset initializer, which would actually start bootstrap the cache and start the training. So in order to access the data, so we use so this example uses PyTorch, a triple dataset, where so we have with Python we have a Pyro client, a flight client, to access the to stream the data from cache using flight protocol. This would actually give this shows how to actually access the data, access the head node and stream the data from head nodes. And here we using the chunk, which is the arrow formatted record batch record batch data, to actually convert to a Python list with 0 copies and pass it to tokenizer.
I think this is the most important part. So it basically allows to do 0 copy from Arrow to PyTorch or through any tensors, which is extremely fast compared to serializing this from disk, right? Yeah, go ahead.
Yes, so we use the since we're using arrow format, so it's a 0 copy to convert from one data structure to the other data structure, and specifically on the querying side, we're using data fusion to actually query that specific shard from in-memory data set. So, and in this case, unlike the previous case where the workers are actually loading the entire data set, so this doesn't require the entire data set. It can only stream a specific batch of data, and also without any deserialization cost. And let me start my training.
Yeah, sorry for interruption, but I think we only have 3 minutes left.
Sure.
And
Yeah.
I think you can share the link to the details of maybe this notebook. And maybe before we get out, before we close this out, Andre, do you have any questions or
I think that's
that you are specifically asking?
Yeah. Actually.
So so I think so specifically, I think we are using leaderboard cassette. So we want to understand how a leaderboard cassette is being utilized outside of inference today. Is there any specific use cases on the data side, on the usage of inference, on the usage of leaderboard cassette, and how what challenges the community is seeing using leaderboard cassette for those use cases. And we also want to see, I know we have a issue open on the GAG scheduling side. I think we are interested to actually see use the feature, and also want to understand if there is any way we could autosize the leaderboard cassette. So basically, in our use case,
these are great questions, I guess, since we are likely running over. So my suggestion is to post the link to your presentation and the notebook in the channel.
Sorry, can we talk about it next week when we have more time? Maybe because I would love for leaderboard cassette committers and maintainers to talk about it. If I know Abdullah is here, and maybe other folks as well.
Yeah, happy to talk about it next week. But in general, like the LeaderWorks, they were designed for multi-host inference, but we haven't heard any use cases outside that so far. It's not that it cannot work. It's just that this is the target use case for that API. It's basically a group of pods as a unit of replication, right? And auto scaling. Anything that would require this semantic, I mean, WS should be a good fit.
Makes sense. Yeah, I think we're specifically using we like the semantics of network set for this use case, as we want to schedule the cache cluster as a single unit and scale the cache cluster as a single unit. So I think network set would using the API would greatly benefit for this use case. But I think we can sync an other call on specific features which we would like on the API.
Yeah, sounds good. Let's resume the discussion next week then. Yeah, thank you for the presentation, and thank you everyone for attending, and have a good day.
Thank you for your time. Thank you for
thanks.
Yeah, see you soon.